Hello everyone, welcome to our tutorial on solving the third maximum number problem on LeetCode. This problem asks us to find the third distinct maximum number in a given array or return the maximum if the third maximum does not exist. In this tutorial, we will discuss and analyze two solutions. Woohoo! Bonus! And by examining both solutions, you will be able to compare and contrast their strengths and weaknesses and learn the trade-offs between time complexity and space complexity. And we will dissect each line of code in both solutions, explaining the syntax, mechanisms, algorithms, semantics, and logic behind the scenes. And by understanding the key concepts and the intuition behind these solutions, you will gain valuable insights into problem-solving techniques and how to optimize your code for time and space efficiency. Okay, let's dive in and explore the art of efficient coding. The intuition of solution 1 is to iterate through the given array and keep track of the three maximum numbers encountered so far. And by maintaining three variables, which are named first, second, and third, we can update them as we iterate through the array. And initially, all three variables are set to negative infinity to handle the case where the array contains negative elements. negative numbers. And during the iteration, we compare each number in the array with the current maximum values. And if a number is greater than first, it becomes the new maximum, and we update first, second, and third accordingly. And if a number is not greater than first, but is greater than second, it becomes a new second maximum, and we update second and third. And if a number is not greater than second, but is greater than the third, it becomes a new third maximum, and we update third. And after iterating through the entire array, we check if third has been updated. If it has, it means there is a third distinct maximum, and we return third. Right? And otherwise, we return first, which represents the maximum number in the array. The key intuition is to iterate through the array and maintain the three maximum values by updating them whenever a new maximum is found. This approach allows us to find the third distinct maximum efficiently without sorting the entire array or using additional data structures. Now, let's break down the code line by line. This code starts by defining a class called solution, which is a common structure used in LeetCode problems. Inside the class, there is a method called thirdMax that takes two arguments, self, which represents the instance of the class, and nums, which represents the given array. And three variables, first, second, and third, they are initialized to negative infinity. And these variables will store the first, second, and third maximum values encountered during the iteration. And then the code enters a for loop where it iterates over each element num in the array nums. Inside the loop, the code checks if num is greater than the current value of first, which means num is a new maximum. And if num is greater than first, the value of third becomes the previous value of second. The value of second becomes the previous value of first. And the value of first becomes num, as it is the new maximum. And if num is not greater than first, the code checks if num is greater than the current value of second, but less than the value of first. This condition indicates a new second maximum. And if the condition is true, the value of third becomes the previous value of second, and the value of second becomes num, as it is a new second maximum. And if num is not greater than second, the code checks if num is greater than the current value of third, but less than the value of second. This condition indicates a new third maximum. And if the condition is true, the value of third is updated to num, as it is the new third maximum. After iterating through the entire array, the code checks if the value of third has been updated during the iteration. If third is not equal to negative infinity, it means a third distinct maximum exists, so it is returned as a result. And if third is still equal to negative infinity, it means there is no third distinct maximum, so the maximum value, which is first in this case, is returned instead. The time complexity of this solution is O of n, where n is the length of the input array nums. This is because we iterate through the array once in a single loop. The number of iterations is directly proportional to the size of the input array. The space complexity of the solution is of 1, which means it requires constant space. This is because the amount of extra space used does not depend on the size of the input array. The solution only uses a constant number of variables, in this case, 3 variables to be exact, which are named first, second, and third. And we use these 3 variables to track the maximum values regardless of the input size. Now that we have examined solution 1 in detail, let's move on to our second solution. This solution offers a different approach that leverages set operations and sorting. And during the implementation of solution 2, we take advantage of the built-in set operations and sorting functionality available in Python. And by creating a set of unique elements, we obtain a collection that contains only distinctive values. This set is then sorted in descending order using the sorted function with the reverse to true argument. And the resulting sorted list allows us to easily identify the third maximum value. And by accessing the element at index 2, we retrieve the third distinct maximum, solving the problem effectively. In solution 2, the code first checks if the length of the set of unique elements in nums is less than 3. The set operation removes duplicates, so set nums contains only the distinct elements from the input array. And if the length of the set is less than 3, it means there are fewer than 3 distinct numbers in nums. In this case, the code returns the maximum value from nums using the max function, as there is no third distinct maximum. And if the length of the set is not less than 3, it means there are at least 3 distinct numbers in nums. In this case, the code first converts the set of unique elements set nums into a sorted list in descending order using the sorted function with the reverse to true argument. Finally, the code accesses the element at index 2 in the sorted list, which corresponds to the third distinct maximum, and returns it as the result. The time complexity of this solution is dominated by the sorting operation, which has a time complexity of O of n log n for n elements in the array. Additionally, there is a set operation that takes O of n time. And in terms of space complexity, it's O of n. The set operation creates a set with unique elements from nums, which takes O of n space. Additionally, the sorted result is stored in a list, taking additional O of n space. So based on the time and space complexities, solution 1 is generally better than solution 2 because solution 1 has a more efficient time complexity of O of n compared to solution 2's O of n log n. Moreover, solution 1 has a constant space complexity of O of 1, while solution 2 requires O of n space due to the set and sorted operations. All right, that's all for today. I hope this tutorial helps you in your learning journey. And remember, practice is crucial for mastering LeetCode problems. Please try solving more similar problems and gain familiarity with different techniques and data structures to enhance your problem-solving skills. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye!